Hey everybody, my name is Marcus. I am a developer relations professional at EdgeNode, and welcome to another episode of the Graph Builders Office Hours. Today we have a guest from EdgeNode, Chris Whitted, who's going to be sharing about API key security. And we're going to go into that in just a little bit. But before we dive into that, I want to go through a few announcements before we dive into learning more about API security and making sure that we have a good querying experience when you at the graph now. So first things first, share my screen. And we're going to talk about a new feature with subgraphs and upgrading subgraphs. And this is something that we're trying to communicate very well with the entire ecosystem, that if we have subgraphs on the hosted service, we should upgrade. And we're going to go through that right now. So if anyone here in this call has a subgraph, go ahead and follow through these steps where you go to your subgraphs on the hosted service, and you're going to see this button here, Upgrade Subgraphs. All right. And you can see right here, we have one subgraph that needs to be upgraded. It's a very simple process. Go ahead and click on Proceed. And from here, just logging in. The subgraphs are now being upgraded. And I will also provide links to the documentation and videos about this process. But essentially, we're taking hosted subgraphs and bringing them into Subgraph Studio. And then, try again here. And from Subgraph Studio, it can go into the Graph Network. If there's over 10,000 queries per month on that subgraph on the hosted service, it will actually go to the Graph Network automatically. So from there, that is the announcement on the subgraph. And then also, one thing that one of our core development engineers, David Lettercourt, brought up was he asked me to bring up this article. And if anyone out there is able to read through this article to improve their subgraphs indexing performance, they should. This is called 2 Simple Subgraph Performance Improvements, and it's talking about using immutable entities. If you're not using immutable entities, absolutely get to using those immutable entities in your subgraph, as well as using bytes as the IDs in your subgraph's entities. So really important to bring those up. If you're not using those, please go ahead and use those. Those are the 2 announcements for the day today. And with that being said, let's go ahead and I'm going to pass the mic over to Chris, who's going to educate this session about securing API keys. So, Chris, how you doing today, man?
I'm doing all right. How y'all doing? I'm glad to be here.
Awesome. So I'll let you take over here, and feel free to introduce yourself and go ahead and share what you are going to be sharing today.
Perfect. So, as Marcus said, my name is Chris Whited. I'm a principal software engineer at EdgeNode on the product engineering team. So working on a lot of the UIs of the graph in the graph ecosystem, Studio, Hosted Service, Explorer, etc. And that has a lot of different factors, different things. And one of the biggest things is that it means I spend a lot of time querying subgraphs. And so it has provided with me an ability to see different sides and different ways to query subgraphs and understand ways to utilize API keys, secure API keys, and how, in my opinion, some of the best practices for using them to query your subgraphs. So today's conversation is largely around the security of API keys. So we know API keys are integral with querying subgraphs because what they allow us to do is query a subgraph published to the graph network. They're a way to associate a query to a user, and then that's how query fees are paid, and those query fees then go to indexers, and this is a big powering point of the graph ecosystem, right? Because we believe in decentralization, we have these decentralized network of indexers between indexing rewards and query fees. We pay those indexers for their service of indexing our subgraphs. So with API keys, one of the things that we've noticed is wanting to make sure that when users who are building dApps are building them, that they make sure they do what we can to secure those API keys. So to start, API keys are obtainable on the Graph Studio. Go in, connect your wallet, go to the API keys tab, create an API key. It takes all of 10 seconds, and there you have it. And this value will then be used in your query URL when making requests and querying your subgraph. So there's a couple different aspects to security. I'm going to primarily focus on building a dApp with higher level security. But one of the things I want to mention is that within API or Subgraph Studio, we can lock down an API key specific to a subgraph. I think that's a really important one to consider as well when we're building API keys and querying dApps. Is chances are if you're building a dApp, you know the subgraph that you're trying to query. Maybe it's one, maybe it's a couple. When you create an API key, there's a security settings tab, and in there, you can set which subgraph you would like that API key to be locked to. So this allows you to go in and say, for this API key, I only want queries going to, just for example, the Graph Network Arbitrum subgraph. There's a lot. Anyway, you can lock that down to a subgraph. So when you're going through this process and you're saying, okay, I have a subgraph, I know I'm querying, I'm building my dApp, I have an API key, I'm going to lock down my API key to the subgraph. That's a step one. That's a big step. Two being locking it down to a domain. And we allow you to lock this down to a multiples of domains. This is handy because it allows you to say, okay, I want to lock this down. When you're in testing, you can lock it to local host. Then you have, maybe a staging environment you can lock it down to, and a production environment, and you can do that from a URL. So that way, when the gateway receives these requests and it looks at the API keys, one of the things it does, it checks the host header and says, where's the domain this is coming from, and has the user allow listed this domain. By default, if you don't allow list any domain, any are allowed. So those are the two API key inherent security measures that we promote. But that being said, if you do those things and then still are noticing that maybe you're having some API key leakage, or that you're noticing some queries going through that you don't think you were querying, and you're thinking okay, maybe somebody is opening the dApp, looking in the network tab, seeing my API key, and then grabbing it and then using it to query the same subgraph, for instance, and then you can spoof the host header and then see those and use those things as well. So this conversation is about that example. It's about, okay, I've locked down API keys to a subgraph or two. I've locked it down to domain. What's the next thing? How do I prevent my API key from seeing the client, or more importantly, the client from seeing the API key? So today I built an example, and this conversation came out of, I built a multitude of examples, and I'll share those at the end, or Marcus, if you want to share those as well on the repo, feel free. So that's what this example is going from. So let's go to that. So this is that query examples repo. There's quite a few examples in here. To start, we have curl, the Next.js app router, which is what we will be focusing on today. The Next.js pages router, Node.js, Fastify is what I'm working on, Nuxt, React, Remix, Svelte, Vue. I'm also going to be doing one in Go, in Python, in Rust, a multitude of different languages, multitude of different frameworks. I want to make sure that I provide a lot of examples, so that way, making sure that we're covering more than just the basic React app, but lots of different things. So like I said, today is going to be focused on Next.js app router. If you're using Next.js, great framework, really cool what they're doing. And with Next 13, they introduced in beta a concept called the app router, which is a slightly different API than the pages router that was being used previously. So when we have a Next.js app router application, you'll notice in our folder here, and if I need to zoom in or anything, please let me know. I'll do that just inherently. in here, the biggest thing is we have this app directory. And this allows us to create page endpoints, because we know that Next uses a file routing system, as well as API endpoints. So for our API key security, what I'm doing is I'm routing requests to my subgraph through an internal Next.js API that is basically a GraphQL pass-through, right? So I'm saying I'm going to build this route file here, and this behaves as a API that is available on the Next server. One of the things that I'll add in here as well is there's slightly a couple more things that need to be done, such as being able to process that only internal functions can call this endpoint. But this is more about an example, right? So I'm going to go ahead and run this as well. Just so we can make sure that we're seeing it. But this right here is like the meat of this example, right? So we have our app router, and we have a directory called GraphQL. And because of our file-based routing approach, it uses the directory name for the API, or for the endpoint, sorry. So in this case, when I want to access this route file, I'm accessing it on /GraphQL. So my endpoint is /GraphQL, and that hits this file. And what's cool about that, so I have this example as well, where we have our URI and an API key. Then obviously this would be replaced with your API key, and then this would be, localhost to start, but then it could be replaceable with, whatever your domain is once you're live in Vercel or wherever you deploy this off to. So let's go through the page. So the point is to be pretty simple. I'm not trying to do a lot of crazy querying in this, or a super complex example. But what this one does is it says, I have a home page, and in my home page, I'm going to use React Query. I really love React Query personally. It's one of my favorite querying frameworks. I think it has a lot of really cool use cases, one of which is that it allows you to provide what your query function is, as long as it, and it's an async function, right? So that means it can be any multitude of things. It can call an API. It can be, it can resolve to a lot of different things and call a database directly, whatever. And what's also cool is that you can then do mutations, and a mutation could be interacting with a smart contract, and the result being optimistically updating your cache, and that, updating your query so that your UI shows those updates as well, and then refetches from your subgraph. So I think, React Query is a really great framework as well. So what we do on our homepage with the app router, this is all server-side rendered, right? So that means that my component, which is going to be server-side rendered, can be asynchronous. And in there, I can then prefetch a query, and I'm going to call it subgraphs in my query cache, and then it's going to use this service layer function, and the service layer function is going to make a request using a GraphQL client, GraphQL request client, and that GraphQL request client is going to be calling my root URI. And remember, from my example, that's just my server. Because when you're interacting at the server layer, it's making another HTTP request to itself, basically. It doesn't necessarily know that it's to itself, but the end result is the server that is rendering the component is going to be making an HTTP request to itself that is rendering the GraphQL route. So in this case, once I have this route set up, this GraphQL route, it's so straightforward, because all I'm saying is I have a subgraph query URL that is my Arbitrum, in this case, it is the Graph Network Arbitrum subgraph, and I'm going to pass in my API key as an authorization header. Basically, we can treat it like a bearer. This is a relatively new aspect of querying an API key. One of the other options is that it becomes a part of the params. Like here, you could do, API key here. But it's better practice to put it into our authorization header. A lot of things with like caching into, and obviously it's still seeable, but if you're sniffing, but it's not, it doesn't get cached in the same way as header params because it is our authorization header. So we are recommending this as well, is that when you are querying a subgraph, instead of passing the API key in your route params, pass that as an authorization header. And that's just best practice. So what this request does is it takes a body that is JSON that is passed in as a post request. We try to parse it into a GraphQL request, which has three parts. We have a query, which is, as we know, the string that is a query. We have an operation name, nullable, whatever, and we have variables, also nullable in case you don't pass any variables. And if that is acceptable, like if the request is parsable as a GraphQL request, we then forward that request to our subgraph. So like I said, it's a proxy, right? In your UI or in your server, you're hitting the subgraph directly, you're hitting this proxy. But what that means, and the important part of this, is that this API key does not touch the client. Because this is a server-side function, it is rendered on the server, it is runnable as an API, and all the requests are going through here, and instead of your API key being in your client and potentially accessible through your UI, whether through the JavaScript bundle that gets sent to the UI or through the request payload so that users can use your dApp, look at the requests, see an API key. So this is a pretty cool way to like next level lock down our API key, is by saying it doesn't even touch the client. And because of the Next framework, I mean, Next is great, obviously, but Next, spelt same thing, I don't have to build a separate API. I don't have to have another, repository or another package in a monorepo, etc. It's all built in here. And Next has a lot of really cool ways to, and I'll add those in a later pull request. Next has a lot of really cool ways to allow you to say, like, only this Next application can hit this API. So that way you're not having, external requests hit your API. It has to be internal, and there's also that as well. But then to your UI, what's cool here, and I included this as well, is I'm using some GraphQL code gen, which I also highly recommend. I'm generating a type-safe schema of my subgraph, but I'm doing it through my GraphQL endpoint that I'm exposing. Unfortunately, it does mean you have to be running the app to run GraphQL CodeGen, but, easy does it. But what this GraphQL CodeGen is really handy to do things where I can say, okay, here's my query. I'm going to use this GraphQL function using the GraphQL CLI, CodeGen CLI's client preset, and I'm going to define my query, and this generates a typed document node that handles both the variables and it also handles the query return. And that means that the return of this is type safe. And this is super, super, super cool. I think I had a similar Builders DAO presentation around the Graph client and using GraphQL CodeGen. So I don't want to repeat a lot of that. But anyway, this client, what is returned here is type safe to this query, which means it is type safe to my subgraph. And my CodeGen will fail if I change my subgraph schema without changing my query, which is also really cool. And that means that we can build components that are end-to-end type safe with our subgraph. So if our component says I need a subgraph and I need its ID, some metadata, and the owner, then you have to query those things. If you don't query those things, then you're not, and like from the subgraph, then it's not hitting the component. You don't have type safety. So it allows us to do end-to-end type safety within our to our subgraph or any GraphQL endpoint as well. So super cool. And in this case, yeah, I just have this query function here, and in my page, I prefetch my query and send it into a table, which this uses React Query's dehydration boundaries to handle that kind of stuff. So I won't go terribly into that, but the point being, when this page loads, the data is available and it's already rendered. So it's already running. Let me bring it up and I'll demo. Yep, okay. I'm going to switch my screen again. Data. Here's subgraphs based off of that query. And again, and I'll do this and I'll refresh so that way everybody can see. Here's my network. And you'll notice that it doesn't even make a request because this component is rendered completely on the server using prefetched data from my internal query proxy that doesn't expose my API key. And so this, yes, is next level security. So that was the big point of the demo. I'm going to switch back to the code, and I'm going to have one last caveat, and then I believe open this for questions or wherever you want to go next, Marcus, which is, so this caveat, because there's no silver bullet in software, and everything is about a trade-off. The trade-off here is the whole point of GraphQL. Well, one of many points of GraphQL, one of many advantages of GraphQL is the most expensive part of a life cycle of an application is the HTTP the HTTP layer, right? It's me querying, hitting an endpoint, whether that's REST or GraphQL or whatever, right? RPC, doesn't matter. That life cycle, when you do that, because you're doing it over and over again, right? Multiple different parts of your page, loading multiple different parts of data, etc. If you're constantly doing that, each time you have to go through the handshake life cycle, and you have to grab the data, you have to return the data, you have to say, yep, this data is correct, then they have to render the data. Anyway, this is all expensive, right? It's resource intensive. It takes time, and time being a constant constraint. With this approach, the potential downside is simply that every request that your app makes is now making 2 requests. So I'm querying my internal API, this endpoint exposed here at /GraphQL, and it is querying my subgraph. So this is a really, really good way. It's a really solid way to secure API keys, and that's very, very important. Chances are users will not notice that next thing of oh, this seems like it's making 2 jumps of an HTTP request instead of 1. If anybody mentions that to you, I would be amazed. But the point being, it's still happening. That's something to be aware of. But it also exposes a lot of cool things that you can do with this, right? Especially if it's not a subgraph you maintain. Because what this means is if you have this internal API, you can do so many cool things to it. You can lock it down with JWT authorization so that only authenticated users can hit this API. Like I said, making it only accessible internal as well. But you can also provide additional resolver functionality onto a subgraph into this API layer, right? So if you if I know I work with, but I don't own the Graph Network subgraph. But if there was something I wanted to do where I could aggregate across multiples of queries, I could perform that resolver in this layer and query this layer, which then does whatever I need on the subgraph layer to perform those aggregations, right? So this also gives you some advantages too. But I wanted to bring up everything is trade-offs, and it's in this case that we firmly believe the trade-off is worth it. Being able to secure API keys completely, where our API key doesn't touch our client bundle, but just as a all-encompassing, it does come at that cost of each request is then 2x'd, right? But that's also a great part of GraphQL too is saying, okay, well, I'm going to batch my requests, right? Because this just throws those requests down to the subgraph. So then I could say, instead of just getting just subgraphs like I'm doing here, here. Instead of just saying subgraphs, I could also grab, graph accounts and the graph network, and I can batch my requests, being the point there. Yeah. So there it is. This is the Next.js app router presentation on securing API keys. Please feel free to check out this query examples repo. Like I said, I've got quite a few examples in here, as well as some resources to some great work that Marcus and Simone and lots of others are doing in the ecosystem to do these kind of cool things. But it was something that it just hit me where I was realizing that we were fielding a lot of these kind of questions. And so I wanted to build in public more and start to show some different things that we've noticed as far as like, okay, here's some best practices that we're seeing that not just secure API keys, but also like how to build queries, how to build type safety, how to get the best response out of your queries, those kind of things as well. So this repo is only gonna grow, and yeah. Is it question and answer time, Marcus, or what are you thinking?
Yeah, this can be question and answer time. If anyone has any questions in chat, go ahead and drop them in. For me, as a relatively junior front-end developer, I'm always impressed by you and your ability to just find these concepts and bring them together like you're already talking about. Since we have this new layer, being able to have different subgraphs interact with that layer, I think that's fascinating. For new subgraph developers, and not only subgraph developers, but people who are relatively new at front end, what are some principles that we're kind of building off of here that might be useful in other situations?
Sure, absolutely. So like I said before, from a GraphQL standpoint, I'll start there, and then I'll go into more of a, I don't want this to be React specific, but I'll talk about the React side too. But from a GraphQL standpoint, there are four main areas that GraphQL is trying to solve over REST, right? You have query batching, right? Or let's start with, I need to get more data. With GraphQL, we know that we can define the queries that we want and only return the data that we need, right? And yeah, I know I'm probably speaking to a lot of people who know that, but the point being, let me bring up that service layer again. If I need more data, I include it in the subgraph. But the inverse of that is true. If I need less data, I don't, right? So one thing to always keep in mind is whether it's not going to change the cost of your query. It's not going to change particularly the speed in which it returns. But as you add more data points onto, I shouldn't have said the last part. That's the part I want to approach. So as I add more data points, right, especially nested queries, right? So in here, an owner has an ID, but an owner is a join, right? It says a subgraph entity has an owner entity that it is related to, and I have then access to that entire owner entity, right? Well, that can get out of hand really fast. If I'm constantly adding more and more fields into the owner, and including I can get from my owner back to subgraphs, and then I can create a circular reference, those things can then bite you pretty quick. And that's something that, like, Subgraph as a whole, there's a lot of layers that, libraries that help with, like, okay, you can only do this layer of nesting, you can only do this layer of loops. But the point is, I believe in a principle when I'm building my components and I'm interacting with a subgraph, that I want the least amount of data that I need, right? I want to start there. I want to start with what is the least amount of data that I can use to build this UI. Because I don't want to wait for the return. I don't want to build these massive queries that are more expensive in the in the amount of data that is being returned, and therefore data trying to be processed, therefore data trying to be rendered, right? And some of that can come from subgraph development itself, making sure our subgraph fits the needs of our app, our DApp. We had a great conversation with, I forget who now, but they were talking about how they're building their smart contracts to better work with subgraphs. I thought that was great, right? Like, subgraphs are becoming such a name in the industry that people are updating their smart contracts themselves to better suit their subgraph, to better suit their DApp. I think that's great. I mean, it makes sense, right? Your smart contract is essentially your API to a database. and the database is the blockchain, but like the end result is the same, right? You want to build the best database you can. So why would you not want to build the best smart contract that you can? But from a querying perspective, yeah. And so
super cool stuff.
Yeah, for sure. So the phase that, you know, from a DApp development standpoint, you know, utilize those first principles of GraphQL, right? The things like only return the data that I need, and where to batch requests, where to use nested queries, those kind of things. So that's my first step, is making sure that my queries are what I want them to be, not letting data that I'm not using stick around, not letting data grow too much, understanding where to make the cut, how to use fragments. Fragments are also really powerful GraphQL concepts that allow us to share data. So if I know that I'm going to be using, okay, constantly, I'm going to have an owner and I'm going to have their ID and their display name and, you know, these kind of different things. I can create a fragment of that and then share it across multiple different components. And then those are all type safe everywhere. So then anywhere in any component that I'm interacting with my owner, with a graph account, I get the same data and I can interact with it the same way. I can then create a shareable component that is, you know, a pill that is a graph account, shows an image, shows address, shows an ENS name, etc. That's really powerful too. Fragments are great. And then one of the things I mentioned earlier is type safety to my components. It's being able to say, I love TypeScript. I know it's not always the norm, but I would say if you're in that phase where you're like, should I work on TypeScript? I personally believe yes. I think that it does a lot. I think it's a massive game changer, and has been for quite a few years now. So, but in this instance, like my data is typed to a Subgraphs query, and I can then, you know, iterate through it. And my type here, it knows that, you know, I have an ID that is a string. I have a metadata, which is an object that has these things. And this comes back to that GraphQL code generation approach, where we can say, if I am a component and I know this is what I need, then I can define a fragment that I expect to receive as props. And then I know I can iterate on those, right? So that's a really powerful approach, right? So I could define in here, I could say import GraphQL generated. Yeah. Oops. And I could say subgraph brag. I don't want to do too much live coding here because I don't think it's the point. But then I could say fragment subgraph data, whatever, on subgraph. And then instead of having it in here like this, you know, I could build a subgraph fragment and then iterate through those and then add that as props, right? So instead of prefetching, I could say props, subgraphs, and then, you know, just to save some time here, I won't build it out, but, you know, it could be of type subgraphs, right? So then I know that my props has a subgraphs that is my subgraphs that I'm going to pass in and iterate on, right? So again, intent type safety with your subgraph. And as a DApp developer, I will say that one of the biggest, most important things you can do is if you can guarantee type safety to your API layer, you're ahead of the curve. You're saving yourself tons of time. You're saving yourself tons of effort. You're saving yourself tons of headache, right? If you can know this component expects this type, and I know that my graph, I can't generate my code because my GraphQL is incorrect. That's a pretty good sign that something's going on wrong, right? So these are the things that we can do to help ourselves, right? Use the tools available to us to help ourselves. GraphQL Code Gen is amazing. Graph Client, which one of the other core dev teams, the Guild, has worked on for a long time. It's also great. I didn't integrate that into this example, and that's on purpose. They do a great job building their own examples and maintaining them. So instead of me integrating with their examples, I think I just put a link to their examples. So those are some big ones. Now, I don't want to take a ton of time in this next part, but I'll get into it. And that is talking about React query performance. So not React query, the framework, but React the framework. One thing that I see, a lot of pitfalls I see, the number one pitfall that I see when I'm helping people build dApps is that they get too hasty with use effect and use state. I'm not going to stand on every soapbox here, but what I will say is, what I tell people, on our team when we're working on different things, I personally see use effect as an anti-pattern of React. I believe that it is one of the biggest pitfalls I've seen in query performance, on React rendering performance, on first paint performance, on general app performance, is use effect setting data into use state. And the reason is because, yes, these components are functional, meaning given the same inputs, you'll get the same output. It's saying any change in the cascading tree of my component requires a change in the component, the render code itself, right? And the diffing is really good in React, don't get me wrong, but if I have a use effect that goes in and says, okay, the component has rendered, I'm going to call a use effect that's going to perform a query that's going to set my state, and then from my state, I'm going to set another piece of state that is like an aggregation of the query that I retrieved that says, how many subgraphs do I have? Or how many subgraphs has a condition, or whatever it might be, right? And those then build more state, and then every time that happens, every time the use effect runs, it reruns your state, and that re-renders part of your component, and then another part of your component, and then another part of your component. So use effect into use state is probably one of the biggest things that I see when I'm helping people out with why am I using so many queries? Well, it's because every time your component renders, it re-renders 5 times, and each one of those times is recalling your API, and each one of those is re-rendering your component, and each one of those is costing you a query. So be careful of that. The biggest thing I can say on it is derive state where you can. Meaning, instead of using use state, use variables that derive state from previous state, right? So that's a big one that I recommend. As you'll notice, and there's not a single example here will you see a use effect. And I mean, these are very light. Don't get me wrong. I'm not saying that never ever use it. I'm saying there are other ways to solve those problems. Use React Query, the framework, from TanStack is great. It does a lot of really cool stuff for us. I believe pretty strongly in a lot of server-side rendering, but it's not always available to us. If you have to use a hook, use effect, use state, those are hooks. You have to render, and with the app router, you have to render the client. You have to render the component as in the client, and I can show you that looks like this. You'll see use client appear. That means that whatever is rendered has to be rendered on the browser client, not on the server. And in this case, what I'm doing is just initializing my query client provider that handles the cache from React Query. So it's not a huge deal, but there's other things with that too, right? Like if I'm going to connect to a wallet, most of those connections are browser only. So being able to connect to that wallet, but then having to listen to those changes, I see people lead into use effects that's rerun queries. So stuff like that, I would say. Use effect, use state is a big one. Deriving state where you can. I'm a big believer in state machines. If you work on my team, you'll hear me wax poetic about state machines a lot. I won't get into that a ton here, but that's something to look into. Look into XState. It's a really cool framework that is doing some really cool things with state machines. What it essentially solves is race conditions, and race conditions are a bane of many developers' existence. So definitely check those out. To be able to say, if I am in state 1, I can do action X. And then if I'm in state 2, I can do action X, etc. So I love React Query, but a lot of times I end up using just state machines to render my UI and to interact with my subgraphs, and also to interact with my smart contracts. And it allows me to say, and act when I'm in state X, right? So take in, different parts of Explorer when you're doing like L1 to L2 transfers. Those are state machines that say, check my initial state. Okay, if I'm in this state, go to this. And if I'm in this, go to this kind of things. And allows you to define the flow of a component or a user flow in a really cool way. So I recommend that as well. But that's not necessarily, those were React things. Vue, Svelte, Angular all have similar sort of patterns, right? The point being, component render trees can beyond what you see in the UI, that's one thing. The other part of it is simply, if you're noticing you're making a lot of requests, that's the first place I would look. absolutely, is where am I making this query? Am I in a lower level component? Is it re-rendering? Yes. Why is it re-rendering? Okay. Can I prevent it from re-rendering, or can I prevent, or where I call it? Those will save you a lot. And then in this case, it saves you queries. Queries end up, going to the indexer for their services. So you're paying for that. So spend that extra time. Start thinking of use effects in those ways of like, do I need this? Why do I need this? Prove to yourself that you need this use effect. Like, no, I really need to have this because it does this. So those are some big ones that first come to mind. GraphQL first principles, React first principles. Yeah.
Awesome. Thank you so much, Chris. And by the way, is my microphone loud enough? How's that sounding right now?
That sounds good.
Sounds good. Good. Well, whenever you are teaching any course or any front-end curriculum, let me know, because you are so passionate about front-end. I really appreciate how much you care about optimizing queries, about optimizing the entire front-end, about making sure that there's security. It's clear that your knowledge is not only that you have a lot of it, but you're very passionate about it. So thank you for sharing your time with us here today and building this repo as well. So for those of you out there who have not seen the repo, it's in the chat. I've put that up there for the existing, for the example queries. And I haven't seen questions in the chat, but for you, Chris, I'll say from me to you, just thank you so much for taking your time here and really sharing your wisdom with everybody. And I'll let you have the last word. And thank you, everyone, for attending. Chris, go ahead and take it away.
Oh, awesome. Well, it was great. I think this is my second one of these. I love doing these. I love talking to y'all. And I really appreciate you, Marcus, for letting me on. As Marcus said, you pinged the repo. I'll be working on different things as I can or as I think about them. If you have thoughts or ideas, I think you could open an issue in there. If you can't, please ping in the channel. I'm not terribly active in this Discord, but I am in this Discord. So if you have an example, feel free to ping that you'd like to see, or parts of an example you'd like to see. I would love to chat. Love to work on those different things. I think it's really exciting to try out different things. And I also want to show people that you don't just have to use React. There are other frameworks that exist out there that are good in their own ways. One of the things that you get from hitting like principal level is you start to see like the right tool for the job instead of to a hammer everything's a nail. And I believe that's really important, right? Like the reason that these things exist is because they're aiming to solve a problem. So what are you trying to solve, and how do you approach it? But thank you so much. Appreciate y'all, and see you around.
Awesome. Thank you so much, Chris. And thank you for joining us, everyone, on another great episode of the Graph Builder's Office Hours. Take care, everybody.